Welcome back to Titan Vans. Today we're going to be doing a deep dive on the EX3 electrical system. The EX3 is a standard electrical system that is installed in all of our models and is comprised of most of the items that you see here. To start off, we have our lithium-ion battery. This is a Victron Energy component. It is a 200 amp hour lithium-ion battery. We use multiples of these to create additional size battery banks. So you can go from anywhere from a 200 to a 600 amp hour on our short wheelbase chassis and up to 1,000 amp hours on our long wheelbase. All these will be in increments of 200. So for our 170 or a Transit 148 EL, you can do a 200, 400, 600, 800, or the max 1,000 amp hours. Now we went with these 200 amp hours because these are some of the most energy dense batteries on the market. You can certainly get a 300 amp hour battery or even a 400 amp hour battery, but for the volume that this takes up, so the size, height, width, and depth, this actually has some of the highest energy capacity that we have found. So you might get a 300 amp hour battery that's almost the size of two 200 amp hours. So you actually get more energy in these guys going with a single or two of those 200s than going with a single 300. So that's why we opt for these, and they work really well. Wiring them up in parallel, so you maintain that 12 volt system on here. You just use their communication cables, and they're just all daisied together, so you can expand that battery bank as needed, and all of our models are designed to allow that to happen. Over on this side here, we have our inverter. This is the Multiplus 3000. This inverter will put out a max of 2,400 watts continuously, but has a much higher max wattage output for items that spike, such as air conditioning units when they start up. Now you need an inverter for those 120 volt appliances. So for most of our builds, that's going to include the 120 volt air conditioner unit, microwaves, induction cooktops, water heaters, but all the other 12 volt appliances are powered directly off the battery. So those are going to include your furnace, LED lighting, the marine grade fridges that we use, water pumps, all of those direct off the battery. You don't need the inverter for it. But when you are going to want to add 120 volt appliances to your build, inverter is required to power those loads. This is a pure sine wave inverter, so it produces the highest quality type of 120 volt power that you can get. It's going to be similar to what your house gets from those power lines outside. So it'll power pretty much any 120 volt appliance, even like inductive loads, which can be some of the most difficult ones to power. It also has a built-in charger in it. So this one has a 120 amp charger. So when plugged into shore power, it's going to do two things. That built-in charger is going to connect directly into the battery, and we'll talk how as we go through this system here, but connects directly into the battery. So as soon as you plug into shore power, it will actually begin charging up your battery bank at a rate of 120 amps. And then, if you're plugged in for 2 hours, that's 240 amp hours that it's going to recharge whatever size battery bank you have. Okay, so you just multiply by the time to get the amp hours from that charge rate. Also inside of this is a built-in transfer switch. So when you plug this into shore power, it automatically takes over and will pass that 120 volt shore power signal from the input side of the inverter directly to the output without actually inverting. So it's using that 120 volt power that you're getting in from shore power. So whether that's a 15 amp or a 30 amp plug that you're utilizing, will come in, transfer to the other side, and then gets distributed to the rest of the 120 volt system, which you can actually control up here on the control panel. This is a little display here, and I'll talk about that in a little bit more detail as we go. Okay, so that's the inverter side. I'll be kind of bouncing around with some of these different components as we go through, because obviously they are all connected as a part of the electrical system. But the heart of this system lies here on our PreUtility panel. So this gets mounted directly behind your utility panel. Okay, and I'll show you an example. Got it over the side here. So our utility panel is what you actually interface with in our van. So this is the front end, battery disconnect switch, 12 volt fuse block. You got your solar charge controller, a little negative ground pass through here. So all the wires are going to come through these holes here to connect up to your 12 volt fuse block. This is really all you actually have to interface with in the event you want to shut down your system if you're doing some diagnosis and you want to access like your 12-volt fuse panel, all of this is mounted actually right in front of this in all of our cabinetry. So it's just 6 screws, this comes off, and boom, you have access to the entire electrical system. That easy if you need to service it, okay? So on this guy, this is what, again, we call our pre-utility panel. Lots of components and a lot of functionality going on here. So I'm gonna kind of walk through it step by step, talk about what each of these components are and why they're in our system, okay? To start off, we have the brains. Right here is our BMS. This is another Victron component. You'll notice it has the communication wires here that connect directly into our batteries. So the batteries are actually communicating with the BMS to tell it what the state is. So that includes temperature and voltage. So how much power is in the battery, that's how the voltage is what's gonna indicate. And then the temperature, so if it's too hot or too cold, it's gonna send that information up here to the BMS, okay? The center stud here on the BMS is what connects directly to the positive stud on the battery. That's what's gonna isolate the battery, so it doesn't actually connect to the loads or grounds directly. It actually all connects through this center stud, so that's what allows the BMS to disconnect the battery if needed. We'll talk about the loads and the charging side. So let's start on the charging side here. So you'll hook up all your charging your charges, anything that's gonna be charging your battery onto this side. So this is gonna include solar. This will also include alternator charging. I believe those are the only 2 items that we're gonna have connected directly to here. And so that allows this to isolate if needed. So lithium ion batteries do not like to get cold. Now they still will perform, but at freezing, so roughly 0 degrees Celsius, 32 degrees Fahrenheit, this battery will send a signal up to the BMS and it will not allow the battery to charge. It will still allow it to discharge. You can still run your loads such as lights, the inverter will even work, but it won't allow you to charge. So even if you have sun, so it's a sunny day, but it's really cold out, if the battery gets too cold, it won't allow you to charge, okay? So now how we deal with that, we have a heating system that we integrate with the batteries. Has temperature sensors that will turn that heating pad off and on as needed to keep these batteries warm. We have tested, we've built a freezer system, like a cold temp system, put the battery inside there with just a heating pad on there and tested whether it was functional or not. So you can Bluetooth into these batteries. We also tested it off the BMS to make sure that charging and load was still enabled. And we tested that down to -5 degrees Fahrenheit. So we took the freezer down to -5, put the battery inside there, put our heating pad on there with all the temperature sensors and relays that are required, ran the system, and it stayed fully functional at -5 degrees Fahrenheit until the battery essentially ran itself dead off of, because it's powering the heater pad, right? So this will stay very warm. If you have a big battery bank, it's gonna stay warm for a very, very long period of time, even if it's exposed to that -5 degrees. Now, if you're running your heater inside your van, you're actually in your van in the cold temperature, typically this is not going to be experiencing that -5 degrees Fahrenheit. That's a pretty extreme situation. That's like it's parked out in your driveway, you're not driving the vehicle, you're not actually in it, and you just leave these batteries out in the cold. No big deal. System is totally designed to handle it. The batteries can get cold, it doesn't damage them. You just don't want to charge them when they get cold, okay? And that's what this BMS is essentially preventing. It's preventing any damage from happening to your to the battery and to the battery system. And all the other components that we've designed in, and even the logic, so we actually have to program all of this, ensures that you cannot charge this in any way off of the inverter, off of shore power, off of the alternator or solar will not allow you to charge if it's too cold, okay? So if it does get too cold, it's just gonna shut the system down, and we'll talk about how to recover it with some of these additional components that we've installed, okay? So that's the charging side. And then the load side over here, so this is the battery, and if it's in a happy state, so it has plenty of power and it's at a good temperature, it's going to allow you to discharge. Now you can actually discharge, again, remember, charging cuts off at 0 degrees Fahrenheit, 32 degrees Fahrenheit, 0 degrees Celsius. Discharging will not disconnect on these batteries until -10 degrees Fahrenheit. So that has nothing to do with the heater pad. That's just if the battery gets by itself down to -10 degrees, it will disconnect loads. But before then, everything will still function. So you're still going to be able to run the inverter, you're still going to be able to run your lights, your fridge, the furnace, all of that stuff will still be functioning down to -10. But with our heater pad system, I mean, it would have to be extremely, extremely cold for that battery to get down to that temperature, or the system is shut down and there's no heating, the heating pad's not even working, and it's, you know, below -10 out. That's kind of the only way that I can really get down to that sort of temperature. So loads here will allow you, this will go directly to that utility panel that has that fuse block on there, and that's where it gets distributed to the entire system. So everything is fused and protected in all of our vans. Now, you'll notice here that we also have a DC to DC charger that's connected directly to loads. So now we're starting to get into some of the backup power supply. So this is part of the redundancy and the ability to off-grid recover this system in the event that it does get too cold or the power discharges too far, okay? So what we typically see, this is normally during winter time, temperature gets really cold, heater pads are running, solar panels are covered in snow, they're not driving the vehicle, and they're not plugged into shore power. And so this thing is trying to keep itself warm, but eventually the battery bank will run itself you know, to where it runs out of power, and then the system will shut itself down. So loads are disabled due to voltage, not due to temperature, but due to voltage. And then eventually the battery's gonna get cold as well because it's not heating itself anymore. So now you kind of have a twofold situation where you have a really cold battery and the battery has drained itself, so it doesn't have enough charge to turn the system on. And that's where this little component comes into play here. DC to DC charger connects directly into the alternator. So when you start the engine, typically this just sits idle. It doesn't get used at all until this system actually shuts down. So there's some logic there that we've programmed in that will enable this if this is disabled. And so this guy will kick on if this is shut off, and it sends power directly to your loads, 12-volt DC loads, right? So this will send power to your heater pad. It'll send power to your Webasto furnace. It will send power to your LED lights, to your fridge, all of those DC power. So you still won't be able to run your microwave, your air conditioning unit, which is too cold anyways, you know, or your water heater, because those are all 120-volt powered devices, right? And all we've done here is start the engine. So we now have power coming to our backup DC power supply. It feeds into our DC loads, which now allows our inverter to slowly start to our battery to slowly start warming back up. We can also expedite that by turning our heater on so we can get the ambient temperature inside the van warmer. Once the temperature gets up to the point where we are allowed to charge, we now have a second DC to DC charger that we program as a lithium-ion trickle charger. So in the event that this battery has discharged itself so far down because it was running those heater pads, even if you get the temperature back up, the lithium ion will not come back online. There's not enough voltage to actually kick the BMS on. So this trickle charger, again, is programmed so it cannot charge until the temperature is reached. So it's got some logic that we've programmed into it. So this guy allows us to get the battery back warm. Once it's warm, this one is enabled. If the voltage is too low, then it will begin trickle charging. So you notice it's actually connected directly to the battery stud. So it bypasses the BMS, connects directly to the battery, and this will act as a pulse width modulated signal. So it's actually pulsing to the battery to kind of slowly bump that power back into it. If you hit a lithium ion too hard when the voltage is very low inside the battery, it can damage the cells because they don't have time to equalize inside the battery. So you want to do it in a pulse width modulated signal. So it's kind of just doing this really, really fast. You can slow it down, but that will allow the battery to safely get recharged until it has enough power to re-engage the BMS. At that point, since the temperature is already back up to temperature, it will allow for a full rate of charge off of the alternator because we have the engine running. So nothing had to be done by the customer, literally just start the engine, and all of this happens automatically depending on voltage and temperature, right? So we brought the temperature back up, we trickle charged the battery, we got the power back up, And as soon as the power got back up, boom, BMS kicks in, full rate of alternator charging, which at an idle for our vans, you'll get around 100 to 120 amps off of the factory Mercedes alternator. Now, if you had a dual alternator system, we will get 400 amps of power flowing back to our battery bank once the BMS is re-enabled. Okay, so a lot of power if you go with that dual alternator. So if you have a big 1,000 amp hour battery bank, that's gonna allow you to recharge that battery really, really fast. For a smaller battery bank, anywhere from like 200 to 600 is kind of on the cusp there. The factory alternator is gonna put out enough power to be able to recharge that battery in a reasonable amount of time. Now, if you want it faster, you can always add a dual alternator, it will never hurt. But for like a 200 amp hour system, that means it would take you 30 minutes of idling your engine, and you're gonna have that battery fully recharged. So a little overkill for that size of a battery. Okay, so that's the BMS. We talked about charging, we talked about loads, we talked about the backup DC, the backup trickle charger. Now, what if you don't wanna idle your engine? Okay, well, we've also designed that entire functionality, all of that backup recovery into the shore power side of things as well. So this item down here is actually a power supply. So this is a 120 volt AC to 12 volt DC power supply. So when you plug into shore power, normally this guy just sits idle if the system is all functioning properly, and the inverter charges the battery and does its thing. But in the event that the battery is shut down, it means that the inverter is not going to function, okay, because it requires the battery to be up to temperature for the inverter to function, because we don't want to charge at too low of a temperature. So now this power supply takes over just by plugging in the van and powers your DC loads just like this device does. So now we have power coming into our load stud here. This will send power to our heating pad, our lights, our heater, exactly the same way. So now heating pad starts to bring the temperature of the battery back up. We can expedite it by turning on the heater, right? Bring the whole system back online faster if we want, or just plug it in at the house and let it do its thing, okay? So now this brings the temperature back up, and the inverter, if this is also in a low voltage state, we've programmed the inverter to also act like a trickle charger. So once temperature is back up and happy, inverter knows what the voltage is of the battery, and it will act like that pulse width modulated trickle charger, just like this device will, and allow you to recover the battery from that low voltage. Once it gets up to a happy temperature and voltage, then the full rate of the charger kicks in, which is that 120 amps of shore power charging direct to the battery, okay? Again, all of that happens automatically. All you have to do is plug the van in, and the system has a lot of logic and backup to allow that to happen by itself, okay? Now, the last feature I want to talk about, a couple of them actually, we also have integrated in the system a jump start capability for your van. That means if you leave your headlights on, or you're listening to music, or something just happens with that Mercedes or Transit, the Ford battery, and you can't start your engine, you go to start and it's just click, 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 okay? You can jump start this whole system off of your backup battery. You have additional batteries in your van, why not use them to go ahead and get your engine back up and running? Okay, so we've built in an additional relay into this system, also temperature controlled, so it's communicating with the rest of the system. And this will allow you to actually jump start directly off of these batteries right to your engine. And there is a switch mounted right in your dash. You double click the switch, you'll hear a little click. That's the relay closing here. Now you're actually running your vehicle off of the lithium-ion batteries. Start up your engine as normal, push the button, turn the key, depending on the year you have, and vehicle starts up as normal. And as soon as it does start up, your alternator is now producing power, so it'll start recharging your factory battery just like normal, and then the relay will automatically close or open depending on the voltage difference between the two batteries, and then the alternator will start charging just like normal through the charging stud to the battery stud. So all that happens automatically. All you gotta do, double click, get your engine running, and drive away. Don't have to do anything else after that, okay? So really nice sort of safety emergency feature built in there. Another cool feature down here, you notice this guy is called a shunt. A shunt is essentially like a bridge, but it counts every single electron in and out of the battery. So when we initially QC our systems, we fully charge up the battery and we set that at 100% SOC. So that's state of charge, SOC. We call that 100% after we've charged it up for a full day, we've left it there, we disconnect the system, it goes back down to sort of like its top resting level, which is like its max power it can hold. And then we calibrate it at that point, we call that 100%. And then every electron that goes in and out of the battery from that point on is calculated to determine how much power you have inside the battery. So as an electron goes out of the battery, the negative terminal connects right here, it flows through the shunt to the ground, and every single ground in your van connects right back here. We don't hide grounds in the chassis on the van somewhere. They're not screwed in all over the place. You're not gonna find a ground underneath the driver's seat or the passenger seat. Every single ground in our van runs back to a single point, which is right here, this big 600 amp bus bar. That allows really easy diagnostics because you're not tracking down these random connections that could be causing some faulty connection and causing you to not allow that part to work. So that's why we do that. It's a lot more wiring, so you'll see a lot of companies kind of skip that and they'll just kind of like ground to whoever the closest spot, because it's a lot less wires and cost. But man, if you got to track that thing down, it could be behind wall panels, under seats, under the hood, under the vehicle. If you've done this on your van, you know exactly what I'm talking about. It's not fun. So everything comes back here. So all those electrons have to flow through this one circuit, which allows us to count every single one. And then when you charge, it's going to flow the other way, right? So all the electrons are going to come in. Now, technically, physics, it's actually all reversed. We're not going to get into that, okay? Let's keep it simple here today. Comes into the battery through this as we start charging, and that allows us to know exactly how much power is left in the battery system. So that's called a shunt, and that communicates right up here on our lovely control panel. So this is really what you're interfacing with on the day-to-day. So here is our battery monitor. This uses a communication cable, connects directly to the shunt here, and this will give you a readout. It actually tells you temperature of the battery. It will tell you voltage. It will tell you current going in and out of the battery, and it will tell you wattage, which is essentially the same thing as current. So this is how you can tell exactly the state of your battery. You can also Bluetooth into the battery monitor. You can Bluetooth into the battery. You can actually Bluetooth into the BMS and each one of these devices. So you have a lot of diagnostic capabilities just with that Bluetooth app as well. So here's our control panel. This is mounted up in the van. This is all kind of in the back in our utility area in the electrical, which you're not needing to access. So it's gonna be like gear storage and stuff. This is up inside the van. This is how you actually control all the different components in your van. So up here, we have the ability to turn the inverter off and on. Now we opt for analog controls on a lot of our stuff because you could go with a single digital display. Victron offers it. You can connect everything into a digital display, but if that digital display malfunctions, nothing works on your system, right? Not a single thing. You can't turn a water pump on if it's connected into that digital display. So we like to kind of break it apart, go with analog controls on a lot of these things because we know they last. It's a little simpler for a lot of people to flip a switch, then kind of dive into a touchscreen menu. And then again, some of those menus, like those screens, if they get too cold, they won't work. If they get too hot, they won't work, right? So it's nice when you got these sort of like hardware components that you know are gonna work and very, very, very rarely fail or have issues. Okay, so right here, we can turn our inverter on, boom. Inverter kicks on. Again, that's the inverter here. So it's 120 volt power, so it's pulling power from the battery, 120 volt power, and then it sends that power right up here to our 120 volt breaker panel. This essentially, we utilize this both for safety protection for having inline fuses or breakers, but it also allows these to be switches so we can control individual components. So we might have an air conditioner, a microwave, we might have our induction cooktop, and a water heater. And we could turn each one of those off and on just with those little switches right there, and you'll have little indicator lights and labels on the side there. So that's the 120 volt side. If you plug into shore power, you're also gonna wanna go ahead and turn that inverter on, and it will start charging up your battery, and then it sends the power directly up here, but you're actually not running off of your battery at that point, right? So all the power's right here. You use it the exact same way. I can turn on my air conditioning unit, but I'm actually now, this switch is actually powered directly off of that shore power, okay? Down here we have our Webasto. We can upgrade this to a smart temp controller, so it's a little bit different user interface and has some additional functionality if you want it, the ability to like set a timer and set it up on a program to like start automatically in the morning. But this simple dial here allows you to just click the unit on, and then you can adjust temperature just by rotating the dial, so you can go hotter or cooler, and it works just like your house. Once it reaches temperature, it does have a temperature sensor in it. Once it reaches temperature, it'll automatically cycle the heater down. Once it drops below that temperature, heater kicks back on to get you back up to temperature. And when you're done, you just click it off. Okay, over here we have 2 switches. Top one is going to be for our water pump. This allows you to turn the 12-volt pump off and on from a more convenient location. We also have a second switch for the water pump that's on the back of our wheel well cabinets, because we also have a rear utility wash on the back of one of our cabinets that you can use outside the van for like washing off dogs, bikes, surfboards, fly fishing gear, whatever your sort of passions are. So you have 2 switches, 2 different locations that they control the same water pump, so you can pressurize the system. You want to turn it off when you're done so you can depressurize. That way, in the event that a part fails, or you leave a valve open or something gets knocked open while you're driving, you're not going to just have water coming out all over the place. So once you turn that off, then the pump will not produce any pressure. Last switch here is for our water tank heater pads. So this switch right here actually is essentially an on-off for heater pads that we integrate onto our freshwater tank and onto our gray water tank that's underneath the vehicle. So this allows you to keep them from freezing in cold temperatures, but also allows you to de-thaw them in the event that it does get frozen. So this is like an enable switch, but each heater pad actually has a temperature thermostat in it as well, which once you turn this on, it will automatically turn off and on as needed with that thermostat. So that's what that second button is right there. But this is really what customers are interfacing with on the day-to-day when they're using their van, right? Using the inverter, checking their battery, water pump, heater pads, and the heater. That's really all you need up front. And then we put light switches, obviously, in sort of more convenient and intuitive locations. You can turn lights off from multiple locations in the van. And that leads me to the last component here on our utility panel, which is this white bar here, which is the dimmer module, okay? This is where our lights come to. So for our overhead lights, it is fully dimming. It's press button, so you can turn them off and on with a single press of the button, and then you press and hold the button to dim. The dimmer module does all the heavy lifting, so it's a really easy way to wire up multiple switches to a light without having to wire like 3 ways and crossovers and using latching switches and all this different stuff. These are all momentary switches, so you just push them, they're connected. As soon as you release it, they're disconnected, right? And so you can wire a whole bunch of them up in parallel. They all come back to here, and this dimmer module doesn't know which switch you push, but it just knows a switch was pushed. So you could have 100 switches in your van if you want. Each time you pushed any of them, it would turn the lights on. And then you could go to any other of the 100 switches if you wanted, push them, and it would turn the lights off, right? Because they're all wired in parallel. And then if you press and hold, it will dim or brighten. You can release and it'll go the other way. But again, it doesn't know which switch you are pushing because they're all wired in parallel. So it's a really easy way to wire up sort of multi-switches and have it off a single dimmer module and not have to get too complicated with all of the switches throughout the van, right? So, and you can use really small gauge wire as well because you're just using those switches as signal wires. They're not actually carrying any current. So even if you have a ton of LED lights and say you're 20 amps to power all your LED lights, that'd be a lot, super bright. Each LED is usually around like 1 to 1.5 amps. If you had that many though, you don't have to run big gauge wire to all your switches. You can use really small gauge wire to control it. And the dimmer module, again, does all the heavy lifting. So you have power coming in and then you have power going out. Those wires you would want to size appropriately for the number of lights you're powering and make sure that your dimmer module can actually handle that amount of power as well. Awesome. So that was a lot of information, but I hope you got a little bit better understanding of kind of what's going on under the hood for our electrical X3 system. If you have additional questions, leave them down in the comments. We'll do our best to answer those. And we can dive into specific components if you guys want, but let us know kind of what you want more details on here. But you know, a lot that goes into these systems, a lot of testing, and these have been put into place for several years now in our vans, and we have had fantastic results. We've had very, very few issues. It's super simple for customers to interface with and to recover the system. So a lot of awesome things. We don't sell this as an individual component. These only come with our full builds just because of how complex they are. And even though, you know, we have a nice little layout here that's all standardized, actually wiring this up into the van and then having to go in to program each one of these devices is not trivial. And so again, this is not a standalone product, but if you're doing it on your own, hopefully you can get some inspiration from this. Or again, if you're just kind of wanting more information on the X3 electrical system and why we utilize it and developed it here at Titan Vans, hopefully this video gave you some additional insight and understanding. So hope appreciate you guys watching the video. Stay tuned for more. Hit that like and subscribe button and check us out at titanvans.com. Again, we'll see you on the road.